imagine you are navigating a massive cargo ship through a severe, blinding storm. You've got an artificial intelligence system guiding you, and it is, it's brilliant.
Right, it's supposed to know everything.
Yeah, exactly. It has read every maritime map, every weather report, and every nautical history book ever written. But suddenly, as you're approaching this really jagged coastline, this brilliant AI confidently tells you to steer directly toward a safe harbor.
Which sounds like a lifesaver.
You'd think so, right? So you turn the wheel, but the harbor doesn't exist.
Oh, wow.
Yeah. The AI just hallucinated it because of like a weird glitch in its historical training data. I mean, it doesn't actually know what rock is, doesn't know what water is.
It's just guessing.
Exactly. It only knows what is statistically probable based on past text. So, welcome to the deep dive. We have a really fascinating exploration lined up for you today, unpacking a massive claim coming out of a company called AIX Global Innovations.
Yeah, and it's a big one.
It really is. We are decoding their assertion that a completely new class of intelligence is emerging, like a shift from AI that merely predicts things based on the past to AI that actually executes what they call real-time adaptive autonomy in the physical world.
Right, and it's a profound transition in how we even conceptualize machine intelligence. What we are really unpacking for you today is the difference between a system that, guesses the right answer on a screen and a system that can continuously coordinate physical action in the real world.
Yeah, a huge difference.
Absolutely. If you are involved in enterprise operations, logistics, or really managing any kind of physical infrastructure, you are getting a front row seat to how operational systems are moving away from static rules-based software.
And moving toward what exactly?
Toward living, self-coordinating ecosystems.
Okay, let's unpack this right away because the fundamental shift here is just wild. The analogy that kept coming to my mind when looking at this concept was about driving a car.
Okay, I like that.
So the traditional AI we are all used to right now, the large language models making all the headlines, it's like having an incredibly well-read, brilliant backseat driver.
Right, they know all the routes.
Yeah, it can look at the map, it can tell you the history of the roads, it can predict where traffic might be based on yesterday's data. But this new adaptive autonomy AIX is building, it claims to actually have its hands firmly on the steering wheel in live, unpredictable traffic.
The backseat driver analogy is a really good starting point, but it actually misses one crucial element that gets to the heart of what AIX is doing.
Oh, really? What's that?
Well, that backseat driver can give you a statistical probability of what happens next, sure, but the backseat driver doesn't feel the car sliding on black ice. They don't feel the steering column vibrate or, the tires lose friction. That physical feedback loop is entirely missing from legacy AI.
Because they're just in the backseat talking.
Exactly. And to understand what AIX Global Innovations is actually selling, we have to establish why that missing physical feedback loop is such a critical flaw in current systems.
Right. The limits of prediction-first AI. Now, just to offer a little playful pushback here, are we being a bit too hard on legacy AI?
How do you mean?
I mean, large language models can write functional code. They can pass the bar exam. They can synthesize vast amounts of text in seconds. They're essentially miracle workers of pattern recognition. So calling them flawed feels almost ungrateful,
I get that, and they're absolute marvels of pattern recognition. There's no denying that. I mean, passing the bar exam is an incredible feat of historical data retrieval.
Definitely.
But this raises an important question, which is the fundamental difference between pattern recognition and true operational governance. Pattern recognition is fundamentally backward-looking.
Because it's based on past data.
Right. It relies on massive data sets to predict the most likely next word or the most likely next pixel. But when you take that historical pattern matching and force it into a physical, operational environment...
Like an autonomous warehouse?
Exactly, or a power grid. When you do that, it breaks. The core problem is that legacy systems drift, they hallucinate, and crucially, they cannot govern execution. Passing the bar doesn't require an understanding of gravity or momentum or physical space.
But steering a ship does.
Precisely.
Which brings us right back to the cargo ship in the storm. The LLM is a brilliant theorist, but you wouldn't want it physically steering the ship because, Well, if it encounters a wave pattern it hasn't seen in its training data, it has no underlying understanding of physics to fall back on.
It just guesses.
Yeah, just confidently guesses based on text it read about waves once.
And this highlights the specific traits that modern physical operations actually demand. An operational system must be adaptive, it must be stable, it must be explainable, and it must be strictly aligned with mission outcomes.
Which legacy AI isn't.
Right. If you are running a regional power grid, a 1% chance of an AI hallucination isn't like an amusing quirk you can just laugh off.
No, it's a catastrophe.
It is a catastrophic failure that leaves millions in the dark. You need true operational governance. You need a system that understands physical constraints, not just one that guesses the next sequence of events based on what happened last Tuesday.
So what does this all mean? If predictive AI is just the theorist in the passenger seat blindly guessing, what does the actual driver look like?
Yeah.
This naturally leads us to AIX's core product.
Seed IQ.
Right, Seed IQ, which is described as an adaptive multi-agent autonomous control engine, or AANCS, which honestly is just a dense wall of technical adjectives.
Yeah, it is a mouthful. But let's break down the mechanics of Seed IQ, because this is where the paradigm actually shifts.
Okay, let's do it.
So Seed IQ stands for Intelligence Plus Quantum. But the most important mechanism to understand here is that instead of relying on pre-trained policies or rigid static rules, it runs on two fascinating concepts.
And those are?
Active inference and physics-driven cognition.
Okay, I want to stop right there. What do those terms actually mean in plain English? Because physics-driven cognition sounds really cool, but how does a piece of software actually interact with physics?
Think about a traditional factory assembly line. That's a system built on static rules.
Right, like a conveyor belt.
Yeah, a central computer is programmed to say, move part A to slot B every 3 seconds. It's incredibly rigid.
So if something goes wrong,
if a machine on the line breaks or a part is slightly misaligned, the whole line jams and stops. The static rules don't know what to do because they don't understand the physical reality of a broken gear.
they just know the code says move part A.
Exactly. Physics-driven cognition means the software agent actually understands the constraints of the physical world. It knows two objects cannot occupy the same space. It understands that momentum carries a heavy object forward.
Ah, okay. So instead of a rigid assembly line, Seed IQ operates more like a flock of birds.
Yes, that's a great analogy.
Because it's multi-agent. You don't have one central boss bird shouting individual flight coordinates to hundreds of other birds.
That would be impossible.
Right. Instead, they are all instantly adjusting to the wind currents, the real-time physics and data, based on a shared goal of moving south without crashing into each other.
That murmuration, that flock of birds, is the perfect visualization of decentralized, continuous adaptation. And it beautifully illustrates that other dense term.
Active inference.
Right. In a cognitive sense, active inference means the system isn't passively waiting for data to arrive in a clean spreadsheet so it can process it. It is actively engaging with its environment.
Like a detective.
Exactly. Like a detective continuously updating their theory of a crime as new physical clues arrive at the scene, rather than stubbornly sticking to a rigid script they wrote before they even arrived.
That makes so much sense.
Seed IQ ingests the business goals, the structure of the domain, the physical constraints, and live data streams. And it uses all of that to constantly update its internal model of reality, producing coordinated action across multiple agents.
It's adapting under uncertainty instantly. Because in the real world, things constantly break.
All the time.
A forklift drops a pallet. A supply truck is delayed by a snowstorm. By relying on physics-driven cognition, the system doesn't shatter when something unexpected happens. It just continuously adjusts around the obstacle.
Exactly the point. It understands the physical mechanics of its environment, rather than relying on a historical data set of what usually happens when it snows.
Here's where it gets really interesting, though. A flock of birds navigating wind currents is a great conceptual model. But let's take this from theory to reality. How does this decentralized adaptation actually govern heavy industry or cutting-edge technology?
Well, AIX targets 3 specific physical verticals.
Right. And the first one is energy systems, which honestly was mind-blowing to me. Because in modern energy environments, inefficiency doesn't actually come from hardware limits.
Right. The turbines and solar panels are fine.
Exactly. The inefficiency comes from what they call fragmented control.
And this is a vital insight into how infrastructure actually operates. A regional power grid is made up of countless different subsystems.
Like generation, transmission, local distribution.
Yeah. And when those subsystems don't communicate perfectly in real time, you have fragmented control. And when control is fragmented, those individual subsystems have to protect themselves against uncertainty.
Right. They widen what are called their buffers. I found the mechanism behind this absolutely fascinating. Mechanical inefficiency in a power grid is essentially caused by the system's fear of the unknown.
Fear is a great word for it.
Because subsystem A doesn't know exactly what subsystem B is doing at this exact millisecond, so it overcompensates, it holds back capacity.
It wastes energy.
Just to be safe, to avoid a brownout. It's like leaving an hour early for a 10-minute drive just because you don't have a live traffic map on your phone.
Yeah, you just don't know what's out there.
Right. You waste 50 minutes of your time just buffering against the uncertainty of a potential traffic jam.
That's a great way to visualize it. And this is where SeedIQ steps in. It acts as an adaptive control layer that eliminates that blindness. By aligning execution across all those fragmented domains in real time, the system can tighten those buffers.
So subsystem A suddenly knows exactly what subsystem B is experiencing.
Yes. You don't have to hold back capacity out of fear anymore. If we connect this to the bigger picture, you are bridging those fragmented silos to create a single, coherent operational nervous system.
And the result is drastically reduced energy waste.
And an increase in usable output, all from the exact same physical infrastructure.
Amazing. And we see that same nervous system concept applied to their second vertical, which is the autonomous warehouse. It's not just a system managing a spreadsheet of inventory.
No, not at all.
SeedIQ is ingesting live physical dynamics to align the entire warehouse with broader business goals. It detects instability before a bottleneck even forms.
Because it isn't just reacting to a spill on aisle 4 after the fact. Through active inference, it's continuously evaluating the physical flow of robots, human workers, and inventory to optimize throughput.
Testing theories on the fly.
Right. It's constantly testing hypotheses about the most efficient way to route traffic before the traffic jam happens.
But then we get to the third application, and this is where things sound almost like science fiction. Quantum computing.
Yeah, this is cutting edge.
AIX says SeedIQ acts as a governance control layer for quantum execution. Now, quantum computing is notoriously unstable, right?
Highly unstable. The environment inside a quantum computer is incredibly sensitive to the slightest interference.
Like heat or magnetic fields.
Even cosmic rays. Executing operations without errors, destroying the quantum state, is one of the greatest hurdles in physics right now. AIX has run preliminary simulations using SeedIQ to manage this.
Right. They specifically use QuATP-based quantum simulation experiments.
Exactly.
Let's translate that for a second. QuATP stands for the Quantum Toolbox in Python. It's basically an open-source digital sandbox that physicists use to simulate quantum mechanics.
Right. It's the testing ground. And in this testing ground, AIX used SeedIQ to explore how to govern major quantum hurdles. One of the biggest roadblocks in quantum optimization algorithms is something called a barren plateau.
Okay, what exactly is a barren plateau? Because it sounds like a geographical feature, not a computing error.
Well, imagine you are dropped into the middle of a perfectly flat, featureless desert in the pitch black of night.
Okay.
Your goal is to find water, which you know is at the lowest elevation point. Usually an algorithm would just feel the ground, find which way slopes downward, and take a step in that direction.
Makes sense.
But on a barren plateau, the ground is completely flat. Every direction looks exactly the same.
Oh, so there's no downward slope to follow.
Right. The algorithm essentially gets lost. It can't find any signal to improve itself. The technical term is vanishing gradients. But the reality is the system is just wandering blindly in the desert.
And how does a flock of AI agents solve wandering in a dark desert?
Well, it doesn't just wander. AIX suggests that SeedIQ's adaptive autonomous control can actively govern this quantum execution. Instead of just reacting to the algorithm getting lost, it governs the environment itself.
By using structural inference.
Yes, to understand the landscape and navigate through or entirely around those barren plateaus, it manages the physical execution, not just the math.
Governing quantum computers and managing global logistics grids. I mean, it sounds incredible. Good. But how do we know this isn't just slick corporate marketing?
Right, where's the proof?
Exactly. How do you actually prove an AI understands physics and structure better than our current multi-billion-dollar deep learning models?
Yeah.
You have to put it in an environment where simple pattern matching guarantees failure.
And that naturally leads us to the hard proof.
The ARC-AGI benchmarks.
The abstraction and reasoning corpus. This is essentially an intelligence test for AI. And it is specifically designed by researchers to defeat systems that rely merely on memorizing vast amounts of data.
So it can't just cheat.
Exactly. To score well on ARC-AGI tasks, A system can't just recognize a picture of a cat. It has to demonstrate true abstract reasoning. It has to solve puzzles involving things like enclosure and topology.
Topology meaning the AI have to understand the physical relationship of shapes, like that a shape actually has an inside and outside and boundaries, rather than just seeing a cluster of colored pixels.
Right. And the data from these benchmarks is where the AIX claims get their strongest validation. We have the performance metrics from the ARC-AGI-3 pre-released games in March 2026.
Okay, let's hear the numbers.
On March 15th, Seed IQ scored 100% across all 3 games, clearing 20 out of 20 levels.
Wow.
But the most important metric isn't the score, it's the efficiency. It achieved that perfect score using only 536 total actions.
536 actions. Let's hold on to that number because the contrast is going to be mind-blowing.
It really is, because on March 21st, the ARC prize administrators changed the rules. They significantly increased the game dynamics and the complexity of the levels.
So the underlying physics of the puzzles shifted.
Yes, and on March 24, Seed IQ ran the newly complex test. Despite the massive shift, it scored 95.49%, still clearing the levels.
And what about its action count?
It only went up slightly to 681 total actions. Now, let's look at the deep learning competitor, an agent named Stochastic Goose.
Right. Before the rules changed, Stochastic Goose scored about 12.5%.
Not great.
No, not great. But to get that measly 12%, it required a staggering 255,964 actions.
Incredible.
It really is. So Seed IQ takes about 500 actions to get a perfect score, and the deep learning model takes over 250,000 actions to fail 88% of the time. This perfectly crystallizes the difference between structural inference and pattern matching.
How do you visualize that difference?
Well, the deep learning model is like someone trying to open a padlock by blindly brute forcing every single numerical combination from memory as fast as they can.
Right.
It takes 250,000 tries to barely get the lock open.
And Seed IQ.
Seed IQ is the master lock picker. It isn't relying on past memory of other locks. It slides a tension wrench into the keyhole. It feels the actual physical mechanics of this specific lock in real time.
Yeah, it listens for the tumblers to click.
Exactly. And it opens the door deliberately in just a few moves.
That is a phenomenal way to understand structural inference. The lockpicker is engaging with the physics of the puzzle in front of them. The brute forcer is just hoping a past pattern works.
And we see exactly how fragile that brute force memory is when we look at what happened to the deep learning model after the rules changed on March 21.
Right. What's fascinating here is that when the complexity increased, Stochastic Goose didn't just perform a little worse.
No, it completely collapsed. Its score plummeted to 0.25%, 0.25%. The other competing agents completely maxed out at 0.5%.
We have to analyze why that catastrophic failure happened, because it's the ultimate proof of the problem AIX outlined at the very beginning of our journey today. Legacy AI is just historical pattern matching.
So when the rules changed,
The historical patterns the deep learning model relied on were suddenly entirely useless. It had no past data of this new environment to draw from, so it broke.
but Seed IQ, using structural inference, adapted.
Exactly. It didn't need past data. Like your lockpicker, it just analyzed the new physics of the new lock in real time and successfully navigated it.
It's a stunning validation. So we have a system that absolutely dominates abstract reasoning benchmarks, and it's built specifically for physical, real-world operations.
Right.
But transitioning from a puzzle to a global supply chain is a massive leap. How does an organization actually adopt this? Because it isn't just buying a new software license or downloading an update.
No, definitely not.
AIX positions themselves as providing a full-spectrum adoption ecosystem.
And honestly, the technology might be the easy part compared to the human psychology of deploying it. Think about the friction of change management.
It's got to be huge.
You're talking about profound organizational preparation. You cannot take a dynamic, decentralized, self-coordinating swarm of AI agents and just violently plug it into a rigid, top-down human corporate hierarchy.
Exactly. Imagine walking into a boardroom and telling a CEO with a 30-year career in logistics that they need to surrender manual control over their global physical supply chain.
Good luck with that.
Right. You're telling them to trust a decentralized system they can't micromanage. That is pure organizational terror for an executive. It's a total paradigm shift in how a business even conceptualizes the word control.
That psychological friction is why AIX structures their adoption ecosystem the way they do. They don't start with the software.
What do they start with?
They start with education and activation. They offer executive certifications and resources through their Learning Lab Central. They are actively trying to rewire how corporate leaders think about autonomy.
You have to dissolve the fear of losing manual control before you can implement the technology.
Exactly. Following that education, they offer strategic insight to clinically point out exactly why a client's current legacy systems are failing them.
Showing them the wasted energy buffers and the inefficient workflows.
Right, and only then do they deploy the tools and solutions. These are the specific, customized configurations of Seed IQ for logistics, smart city operations, dynamic supply chains, and energy grids.
And it makes perfect sense when you look at their target audience. They are going after enterprise operations drowning in complex coordination.
Yeah, and they're targeting government and public sector systems that desperately require resilient autonomy during crises. They are essentially building the infrastructure to manage the infrastructure.
It really is a comprehensive approach to dragging the enterprise world into a new era. So let's synthesize the journey we've been on today. We started by looking at an AI landscape completely dominated by prediction.
Right, LLMs.
Yeah, LLMs that are miraculous at guessing the next word, but hallucinate and stumble the moment they are forced to interact with physical reality.
And we explored how AIX Global Innovations is pioneering a massive transition.
We are moving toward a class of AI that relies on active inference and physics-driven cognition to adapt, coordinate, and execute in the real world, much like a flock of birds navigating the wind.
And for you listening, why does this matter?
Yeah, why should you care about ARC-AGI scores or energy buffers?
Because whether you manage a massive logistics hub, work in corporate finance, or simply commute through a modern smart city, these adaptive multi-agent systems are aiming to become the invisible, self-correcting nervous system of your daily life.
They are the systems that will seamlessly tighten the energy grid to prevent brownouts.
Instantly route your packages around sudden supply chain failures.
And perhaps even govern the impossibly fragile quantum computers of tomorrow. It's a future where the machine doesn't just sit in the passenger seat reading the map.
It actually has its hands on the steering wheel.
Feeling the road. But I want to leave you with a final provocative thought to mull over, building on everything we've unpacked today about how these agents work. We've talked about how Seed IQ uses decentralized agents to navigate reality without a central human boss.
Right.
But what happens when two different adaptive systems encounter each other in the real world? Imagine an autonomous delivery swarm owned by one massive corporation and an autonomous traffic grid managed by a city government meeting at a physical intersection.
Oh, that's interesting.
Right. If they both operate using continuous belief dynamics and structural inference rather than fixed pre-programmed rules and their business goals slightly conflict, how do they negotiate physical reality when there is no central human referee telling them what to do? Who yields?
That is the messy, fascinating frontier we are accelerating toward.
It sure is. The rules of the road are about to be rewritten by the cars themselves. Thanks for joining us in this deep dive. We'll see you next time.